Screen porches, the screening is not going to be the issue. It's going to be, do I have the headroom and do I have the opening from what would be my guard height up? That needs to be where we're going to do that calculation, where that's going to count as opening. So illumination levels, we look at our light levels and keep in mind there's going to be light requirements for stairways, depending on whether they are interior stairs or whether they are exterior stairs. We are expecting landings on exterior stairs at the top, and we're at the bottom if it is stairs going from grade down to a basement or below grade space. We would need one at the bottom. For interior stairs with 6 or more risers, it says I'm expecting to have switching at both levels, and I'm going to have 1 foot candle along the stairs as my minimum light level, just to make sure that we got things relatively safe just from that perspective. Now, here's where I want to get on my soapbox a minute, and this ties in with my already stated feelings about the Energy Conservation Code. So bear with me here. When we deal with the idea of natural ventilation in the home, we would expect that I've got it through these openings that we're going to have to each of the habitable spaces. If I can't provide the 4% of the rooms or that 1.5 feet in the bathrooms, then it says provide ventilation, and it's going to send me to mechanical ventilation, and specifically to what's considered whole house building mechanical ventilation. Now, a whole house mechanical ventilation system basically looks at the square foot of the structure, and it's going to make determinations about my CFMs I need to get air movement through this house. So I've got to have an intake for outside air, and I've got to have a way to exhaust it. Now, we already have exhaust systems, which are called local exhaust systems, which are spelled out in our ventilation from the bathroom, for example, the bath exhaust fans, or you may have an exhaust fan in the kitchen over top of the hood system. So I can use those for how I'm getting the air out, but what I need to add is some mechanism to bring air in to the house and structure. Now, your air intake into your mechanical ventilation system, if you have one, like a forced air, can be used for that intake function. But we're looking at this relationship that comes in. So the first trigger for when I need this whole house mechanical ventilation was you didn't meet natural ventilation through the openings to habitable rooms. The second one is the one that's illustrated in bullet point number 7. We have energy code requirements that say you must measure the air infiltration, exfiltration rates, how tight your envelope is from an energy performance. And you do a blower door test in order to get there. So that blower door test is measuring what we are getting for air infiltration, air changes per hour for the house. And if my house is losing more air through gaps and openings than what is permitted from the energy conservation section, which for all climate zones it's 5, and for certain climate zones it's going to be 3 air changes per hour. And if I exceed 5 in terms of tightness, it says your house is too tight. So you have to have a whole house mechanical ventilation system. Well, the maximum I can have for most climate zones is 5. And it says if you're tighter than 5, then you got to have a whole house mechanical ventilation system. Well, that means the only way I don't make you put in the whole house mechanical ventilation system is when you are exactly at 5 in your air changes per hour and your blower door test, no tighter, but you're exactly at 5, and you've got all of the rooms in the space with, again, 4% of the room area and 1.5 square feet for all of the bathrooms. So basically, in most cases, what that means is all houses per the 2018 code are going to have a whole house mechanical ventilation system. Now, they don't have a requirement that comes out and says that. You've got to look at those two sections and then put 2 and 2 together to come up with, so are we going to make you do it or not? And as I said, it's possible that you wouldn't need one, but in more chances or not, you're going to need it. So just be aware. And that goes back to the mechanical section. It's 1504 that's going to do the calculations on, or 1507, I guess now, that's going to do the calculations on what that whole house mechanical ventilation system needs. But once again, it just frustrates me that we let you figure that out once you start walking through the requirements, instead of just going ahead and giving you the requirement up front. But it's all about the dollars. So, all right, I'm done. I'm moving on. I promise. I'll move off of that, at least for now, unless somebody asks a question, and then I might get back into it. So what we're looking at is we are looking at emergency escape and rescue openings. Now, the code has taken this. We used to always think it was a window and that it had to be a window, when in reality, it could be a door. Now, if you've got a full-fledged door, in terms of full height door, width door, great, but it doesn't have to be. It could be a small little door panel that is the size of what we're going to require for a window. So there are two sections now that deal with emergency escape and rescue openings. And it's not just a window. It's going to say it could be a window, or it gives me the same provisions for a door. And we're looking for that from every sleeping room, from any basement for a new structure, and we're looking for habitable attics. Now, just to clarify, habitable attics are occupiable spaces in a roof structure. So it is above and not considered a story with this code. Heads up for the 2021 codes, it's going to be considered a story above grade plane in the 2021s. But in the 18s, it's not. And so it says this is a area which we're allowing you to use sleeping area. In fact, we assume it's going to be sleeping. It doesn't have to be, but we only make you put the loading that's equivalent to sleeping areas up there. But you got to have that emergency escape and rescue opening up there, because potentially it's going to be sleeping area. And likewise, I need to make sure it's connected to the rest of the house via stairs so that I can get to my required exit door. If not, then it would need its own exit from that habitable exit, habitable attic. So the habitable attic is contained within the roof structure. And here's the secret there. It will expect that you have headroom, you have area. Remember, our areas of room, we're looking for 70 net square feet of area to call it a habitable room. And of that, I'm expecting 7 feet of headroom, and of which I will give you a reduction for half of that, or 35 square feet worth, if you are at least 5 feet. So between 5 and 7 on a sloped ceiling would count for half of my 70 square feet that I need, but the remaining 35 must be 7 or more in headroom in order for that to count as a habitable space via a habitable attic. Now, if I have to end up raising the roof with exterior walls being extended up in order to get the headroom, then that becomes a story above grade plane and not a habitable attic. So it has to be contained within the roof structure proper to be called habitable attics. And the idea is, engineering wise, we've got 3 walls that are sticking up out of the ground, and then it's got some kind of a roof on top of it. And if you looked at, let's just take wind blowing against that wall assembly, well, we've designed it for catching a certain amount of wind in our design and how it's going to perform. And we've accounted for how the roof performs, which if this room is in the roof, or this floor area is in the roof, then we're okay. But if I have to make the walls taller, now I just extended the sail up on the sailboat, and now it's going to pick up more wind, and it's out of the design of what the IRC would include. So that would be beyond the scope of what the IRC does if you went to, again, 4 or more floors above grade plane, or rather stories above grade plane, I should say. So habitable attics, very unique situation in order to gain that extra space up there. If you think about those room trusses that you can order, which already are designed to have the space in them, and you pop the trusses up there, you put your flooring down, brace it off, finish it off, and you got rooms or space instantaneously up in the roof. That was the intention. Now, I don't have to use a truss. I could frame that. But the point being, to get my headroom that I need in there to count as habitable, if I'm having to jack up the roof, or if I have to lift the roof and put dormers on in order to get the headroom, now we've created basically another story up there, and that's the concern.
Hinge trusses is what they call them.
Hinge trusses?
Yeah.
Okay.
They use it a lot on those Cape Cod type of thing homes. They use them a lot in modular homes.
Yeah. Okay. I worked for a modular home company for about 5 years, and we use hinge trusses for transportation purposes. Then we jack them up on the site. And I'm not talking about that type of an arrangement here. What I'm talking about is if you lift the roof itself. So I'm extending the sidewalls up to get that headroom. That's where it is.
Yeah, they do both for attics and for actually, it's what we call them Cape Cods, where they're gonna make somebody living out there to finish it later.
Yeah. Yeah. And a lot of times your Cape Cods, which again have the rafters coming down and they meet the floor level there of that attic space, and yet they don't have the headroom necessarily until you lift that up and put your dormers on or lift the roof up. And again, structurally, we're going to ask you to design that floor to handle a bedroom up there for the future because you ran full stairs up to it, for example.
Yeah, they're all engineered.
So back to my emergency escape and rescue openings, basements. It didn't say habitable basements. It used to. Hasn't for a couple of code editions. So any new basement, the assumption is if you got a below grade space down the road, what's the homeowner going to do? They might want to put a bedroom down there. So we're going to go ahead and have you, while you're building it, put in that emergency escape and rescue opening. So the idea is it's there for use should we need it, because I don't want the homeowner trying to figure out how to do it. Because as soon as you tell them they got to cut this window and opening below grade and put in a window well and stuff, they're going to say, never mind, I don't need a permit. No, I'm not going to do it. And are they going to do it? Yeah. So we'd rather that it be done right to begin with. So we're going to make you do it for new ones. Then we're going to say if there's a sleeping room down there, it must be connected to it, meaning using it. And you don't have to add another one until you add more sleeping rooms down there. But the one must be there no matter whether it's finished or habitable or going to be habitable, just because you got a basement. And then every sleeping room or sleeping area must have it. Now, these must accommodate, again, the emergency responder in full gear to be able to open the windows. So we have requirements on the sizes of those windows. And it will look at looking for those operable windows. They have to be operable without a tool, special knowledge, a key, that kind of stuff, which does get us into some different conditions. There is an exception for dwelling units, townhouses, where I have automatic sprinklers being provided. Then the basement has one means of egress and one emergency escape or rescue opening, or it has two means of egress from the basement. Then it doesn't need to have the sleeping rooms with their own individual emergency escape and rescue openings. But the house must have the automatic sprinkler system per, again, P2904 or equivalent. So It's a very unique exception there. If you don't meet that condition, then you can't use it. Um, look at our grade floor openings. For grade floor openings, we are within 44 inches of the outside grade to call it a grade floor window. So above or below grade, 44 inches, that's a grade floor window. It only needs 5 square feet of opening, of which we have to have at least 24 inches in terms of height and at least 20 inches in terms of width of the clear opening. And as we know, 20 by 24 doesn't give me 5 square feet, but those are my minimums. Now, if I'm not a grade floor, then it has to be 5.7 square feet. And that's to account for the ladder that the firefighter is going to use when they're trying to navigate this window. So that was what the extra 0.7 square feet is going to account for. So these are just showing some examples about the 5.7 square feet. We do want the sill height to be at 44 inches maximum off of the floor, so that we can get to it without the use of a ladder necessarily. And it's looking for 20 inches minimum, in which case then I would be at 41, a little over 41 inches in depth on that window. If I was going with the 24-inch height minimum, then I'm 34 inches in the opposite direction to get to my square foot of 5.7 square feet that I need. For the grade floor windows, same kind of conditions, and we're only looking at 5 square feet. So now we would be at 20 inches wide. For 5 square feet, we're about 3 feet. And for going to 24-inch height minimum, we're 21 inches in width. If we had doors we're going to use, they only need to meet those same conditions. They don't have to be a full height door. They could be just a short little panel that we've stuck in the wall. Again, I don't know how that's going to look, but that's not our concern. If the homeowners are happy with it, then hey, that's fine. We do want to have it, if it is a door, that it does go to the exterior and it meets those same conditions of square feet and, again, tools, special knowledge, keys. For any kind of bars, grills, security covers that you may have in place, once again, it says use from the inside without tools, special knowledge, or force greater than normal operation of the window. Good luck trying to figure out what that is. I just, how much force did it take to open a window? Okay. I'll tell you, if I'm hyped up enough and I got to get through that, yeah, I'm willing to use a little more force than what would be necessary to open that window just to get out of it. We want to check that on the area well concept, that's the outside when we're below grade, that we've got clearance there, 9 square feet of area, at least 3 feet in minimum dimensions. And once we are deeper than 44 inches, then it has to have a permanent ladder, or it's got to have some kind of step arrangement that comes out of it. Now, here's where the 18 code didn't define what we need for steps. It just says provide steps, and doesn't say, in fact, it says they don't have to meet my stair provisions. So I'm not looking for 7 3/4 10s on rise or run geometry for the steps coming out. So they can be anything that you want. The 2021 code said, well, fine, what do you require in terms of ladder? So the ladder, when you look at the spacing off the wall plus the foothold for the rung, and it come up with, well, we need treads that are at least 5 inches. And then it said, what about risers? Well, rung to rung, we end up with 18 inches maximum. So therefore, the riser could be 18 inches. Now, you may end up doing a crawling type climbing mechanism, and it's just kind of pitched to get up those stairs. But that's how the 2021 code addressed this issue. The 18 doesn't give you that language. It just says, you as the authority having jurisdiction say that the stairs, whatever they are, out of that, and it could be landscape ties, it could be terraced, it may be all kinds of different things. You determine whether it's okay or not. Here's an illustration of the area well, that window well, area well concept. 9 square feet, at least 3 feet by 3 feet. The window must be able, or door must be able to open fully in that space. And if we are below grade, then it's going to call for a tying in of a drain in the bottom to your perimeter drain. Because remember, we're going to have a footing drain going around this building because we're below grade. So we'll have some kind of perimeter drain around and tie in the window well or area well to that. We look at those ladder type arrangements, again, inside of the area well if we're more than 44 inches below grade. And as I said, it's going to give me dimensions on the ladder or the steps that are coming up, but the ladder dimensions, it's going to give me those. Rung spacing's 18 inches, 3 inches minimum projection from the wall to the rung so I can step on it going out. And again, it would go the full height of that area well. For emergency escape, if I come out and I'm underneath of a deck, then it looks for 36 inches of headroom, and I can crawl underneath the deck with 36 inches of headroom and get to, it doesn't have a limit on how far I have to go, but it gets me to open area, side yard, or to a public way directly. Hazardous glazing locations. Now we're talking about the safety glazing issues. I look for glass in given components, and I say there's a chance we may run into it during normal operations or in a haste or in an emergency, and therefore I want protection from impact on the glass such that when I impact the glass, if it breaks, it won't create shards that are going to potentially injure me. So we look at the door, we look at anything in a door that's got glass that must be safety glazed. Then we look at swinging an arc from the door, and we go 2 feet from that arc on either side, and in the plane of the door, if we have windows within 2 feet on that arc and we're not more than 60 inches off the floor, then it must be safety glazing. If I'm more than 60 inches, doesn't have to be. If I am more than 2 feet away from the door, then it wouldn't necessarily have to be safety glazed. So it's looking for the side light type thing. It's looking for windows that are next to that door, and that's where it's getting to. Now there is an additional requirement which looks at, and this is misunderstood, it's looking at an individual pane of glass that is 9 square feet or greater. So I'm not talking about a big pane where you've got stiles in there which cut it into small pieces. So it isn't one big pane of glass, it's small individual panes put together in a frame that is over 9 square feet of area. So if you think of the French door or kind of a French window type approach that looks like that, if that was a window, then they're individual panes, and yes, in total they exceed 9 square feet, but because no individual piece of glass exceeds 9 square feet, that does not require me to make that safety glazed. So we look at its lowest edge being less than 18 inches from the floor. We look at the top edge, and it's going to be more than 36 inches from the floor, and we're within 36 inches of a walking surface. And the one you have to watch here is some of the split level homes where you may have a landing, a level that comes in and there is windows looking out from it. And from the inside, it may not be within 18 inches of the floor. But the walking surface and deck on the outside, is it within 18 inches and is it higher than 36 inches from the outside walking surface, in which case that may require it to be safety glazed. So look at them from both directions to make sure you're not missing something. But it has to be, as I mentioned, a big pane of glass. So if it's not that, if they're individual little lights, they don't count. They're not included. You can do you can put a bar across there, which is going to prevent me from being able to necessarily impact it, give me some visual cue as well as a physical protection against the glass. That could be acceptable in lieu of doing it. We look at places like guardrails that do have safety glass, or excuse me, that do have glass in it. They need to be safety glass, especially for the structural glass going in balustrades. If we have multiple panes, we're expecting some kind of a top rail or multiple laminated plies of glass there, so that I have, again, some extra strength protection so that these individual sections won't necessarily separate from the adjacent ones and then potentially fall out, in which case I don't have the protection, or they may break and shatter. Whenever we have wet areas, there's always the concern about the wet area location. And is it within 60 inches of my wet area such that I may fall into it? Now, there's been a lot of discussion about this idea of the 60-inch distance, because our language in the code said 60 inches in directly across from the wet area, which begged the question, what if the glazing is adjacent to the wet area? And I got an illustration of that coming up, which the code was kind of silent on as to where we get there. The other thing before I leave this slide is glazing along stairs. Generically, if the glazing is going to be less than 36 inches above the plane of the nosings of the treads, it needs to be safety glazing. And we expect that to be protected. However, if you have a horizontal member which will meet my requirements for protection against impacting the glass, what would I have on a stair which would be horizontal that may protect me from, it's 34 to 38 inches up, it would be 36.
Railing.
Yeah, sounds like a railing to me. And that's in fact what could be used. But the idea is looking at it from minimum requirements and when do I get there. So let's just run through some visuals here. If it's glass in a door, no question, safety glaze material required. So sliding doors, absolutely, got to have it. Screen doors, storm doors, same conditions. Swinging doors, bathtub enclosures, yes, has to have it. And your shower enclosures, the doors there, enclosure walls, if they're glass, they would all need to be safety glaze materials. Now, side lights, we're looking at its location to the door, swinging that arc, remember the 24-inch arc, and we're going to say, well, is it within 24 inches of the side of the door? And in this case, yeah, it's less than 60 inches, it needs to meet it. Now this one, if it's less than 60 inches, would need to meet as well, because it's within 24 inches. Now, what is in your illustration, and this is inaccurate with the 2018 code, what changed is if it's in a wall which is not in plane of the door. So in other words, it's not in the same wall within 180 degrees of where the door is located. If that's the case, as we're seeing with this angled wall, or even if it was 90 degrees from that door, now what they do is swing that arc from the hinge side on the inward side of the door and see if we hit the glass within 24 inches. So in this case, since it's on the latch side and that isn't in the plane, if this wall continued on straight, then I would swing a 24-inch arc just like we had here, and I'd look for that window. But because it's not in that same plane, it gets a pass if it is even within 24 inches, because it's not on the hinge side of the door. And the concept is I'm at the door and somebody pushes me, or I fall as the door is opening into the glass that's behind me. Whereas if I'm coming toward the door and it opens, now I'm moving to the right. Well, I'm not falling in that direction. I would fall backwards or into this glass behind instead of into the glass on the latch side. Obviously, they'd never seen me try to navigate through glass, stairs, doors, any of that stuff. I can do wonders when it comes to miracles of gymnastics. So anyway, that's what the language is now. If it's not in the same plane, so if this wall went straight, then this window would, unless it was over 60 inches from the floor. But in this case, no, because it's not on the hinge side of the door. For glazing within a wet area, absolutely. So if I'm standing, if it's more than 60 inches above that standing place, then it's exempt. But if the enclosure, I would absolutely need it. Here's where we have an intermediate landing coming down the stairs, and that would be at 36 inches. So it'd have to be, again, higher than 36 to be exempt from the requirements here. Now at the bottom of the stairs, you come down the stairs, and then it says, remember that 180-degree plane that we had from that tread? It looks for glazing that's in that 180 degrees or less, and it says, you're good, you're golden, you don't need to. But if I'm within that 180-degree plane with the glass, and I'm within 60 inches of the actual landing itself, as we see in this shaded area, anything in that shaded area that isn't more than 3 feet off the floor needs to be safety glazed. So that was a change, and that's only at the bottom of the stairs. We don't regulate at the top of the stairs anymore. And y'all can guess what the logic was. People don't fall up the steps. Hello? Hello? I have, but again, it's that's our provision, and they've stayed that way. So just keep that in mind as we go forward. There's provisions on skylights, and they're a little bit tricky to look at. Basically, the provisions were addressing the old days when skylights were single pane skylights that didn't have anything to catch if the glass got shattered, nothing to catch it. And so it would fall down, and those of us that are follically challenged run the risk of having glass rain on us and possibly cut our heads. And so they called for screen requirements underneath. Now, most modern skylights already have 2 panes for energy protection, and the inside pane is a plastic material or some kind of laminate that is going to be able to catch those shards or those pieces that may come from the outer pane, in which case it makes this need for screening almost obsolete. And a lot of the newer ones come with screens anyway. So the requirements there, just be aware that there's language about skylights and its distance from its highest points and to where the walking surface is. And again, looking for the square area, whether it needs to be tempered glass, whether it's a single glazing, or whether the bottom plane in a multi-glazed assembly has 16 square feet or less, and the highest point is a maximum of 12 feet, and the glass is 3/16 of an inch maximum. These provisions are in the code, and they're likewise in your workbook on page 294. Take a look at those and see what's there. Another one that's kind of antiquated is the need for a curb on your skylight. Most modern skylights already have provisions for a curb. What we're worried about is if you raise the skylight up out of the roof and frame it, will water come down and pocket against that upper edge, or will it be shed around it? So I want to have a curb to protect it from being able to bridge that come in to the opening, or likewise to get it shedding around the actual opening that we cut through the roof. Modern skylights have already taken that into account, but this has language about requiring one when we're in those low pitch roof areas. Again, 312 and less. So just keep that in your mind as you move through. All right. Moving to stairs, landings. The purpose is obviously from an egressing standpoint, being able to get from within the structure to my required exit door. And keep in mind, it may not be the front door that's the exit door. We may designate another door as the exit door, but I got to get from wherever I am in the building to that door via stairs. And that will get me, or on the same landing, the same level as where that door is, to get there. Once I got through the door, now I have to have a landing on the outside and steps down to grade. And beyond that, we don't worry about the egress components. So making sure the means of egress path for all parts of the dwelling vertically as well as horizontally through the structure. There were some contemporary houses being built, and these were some of the people that are into the Ninja Warrior type functions and crazes, and they had multiple levels of floors where there weren't a legitimate set of stairs. And you can build a house that way. Doesn't seem practical to me, but what they did was they had, rock walls, they had rope swings, they had, pole climbs, all kinds of things in there. And what happens is when you have those conditions, then I have to look at each floor and say, can I get to that required egress door on the first floor, for example? And the answer would be no, I can't get there via stairs or ramp, which means now I need my own exit from that floor. So if we think about that, worst case, I've got potential for 5 floor levels. If I count my habitable attics and I count my basement, I've got the 3 floors above grade plane plus the basement plus the habitable attic. I could have 4 levels in the house and not have them interconnect via a legitimate set of stairs, in which case I need 5 means of egress from that structure, 1 for each floor. But normally we expect our stairs and ramps to be able to get us to the 1, in which case then that's all I require. Now that door, we used to say 3068 side hinge swinging door. Now we say, what's the clear width? And those that do commercial work know we expect 32 inches of clear width for a door to be considered an egress element. That happens to also work for accessibility when you're using a wheelchair. 32 inches is the minimum width currently for getting through a door with an adult wheelchair user. So that jives for the minimum width, and we're looking for our 6'6" of headroom in the opening, and that gets us our required egress door. So in fact, it may end up being that 3068 door, but what we're looking at is what's the opening. So the leaf of the door is somewhat immaterial compared to what's the opening I'm actually going to have. We need landings on the outside of the door so that I step out and don't get a shock by falling or running right into stairs. However, there are allowances for drop-offs if it's not my required egress door, or if I'm not dealing with accessibility to that required egress door. And interior, we can have stairs coming up if the door doesn't swing over the stairs. And the same would happen for my main egress door with steps, step down on the outside of it to a landing or to ground level. I don't need to have that swing over that step. It's acceptable, but the screen door, storm door can swing over that step, obviously. For our stairs, we're looking for tread risers, 7 3/4 10s. Notice that's different than the 711s that we have commercially being spelled out. For headrooms, we're looking for 6'8" minimum headrooms along the stair components, and that's measured along the plane of the nosings of the treads. We do have allowance for, in limited conditions, 2 lofts and mezzanine areas, and those are used just like we do mezzanines in commercial code, looking at the room or space it's in and limiting them to roughly that 1/3 area limitation. But we can use the ship's ladders, alternating tread devices to those, but they can't exceed 200 gross square feet, and they can't have the only kitchen or bathroom facility. They can't have kitchen or bathroom facilities there. So in other words, if I'm in a hurry and I need to get there, I'm not going to figure out how to use these devices to get up there because I'm having a snack attack and I need something out of the kitchen. Um, Again, if anybody's used the alternating tread devices, they're kind of interesting. They're real easy to go up. Yet when you get up there, walk around, now try to come down, you have to reverse and go a specific pattern. I can't, I got to start off on a certain foot in order to make them work, or else I'm trying to step over a step to get, and it'll be really awkward. It'll be hard to get down. So they're kind of interesting. And as I mentioned, ship's ladders, same condition. I can use those as well. Winders. We do permit winders on our egress stair components in the residential code, not in the commercial code. The winders are permitted within a dwelling unit, and they're looking at a 10-inch tread depth at 12 inches in from the narrow end. The narrow end has to be at least 6 inches to qualify as a winder. So these would be a continuous set of stairs, a flight of stairs, where I have winders in place. They're just an irregular shaped tread is the definition of a winder. And so we come up our stairs, 7 3/4 tens, and now I'm going to measure at 12 inches in, do I still maintain 10 inches? And that goes up around my winders. The minimum depth of a winder has to be at least 6 inches. But at 12 inches in, I want 10 inches. Now that's different from what are spiral stairs. And in my spiral stairs, those have to meet the conditions of spiral stairs, and they've got different requirements than looking at that. So fall protection. This is going to be when we have 4 or more risers, I need a handrail, at least one side of every flight of stairs. It must be continuous for the flight of stairs. Now back to, I may have stairs come up to a landing, go across the landing, and then I got another set of stairs that go up to the next floor. So that's 2 flights of stairs, meaning I could have 2 separate handrails. Now, if it's open, I may run into the issue of, is there a fall risk, in which case I need a guard. That's where we look for that 30 inches of fall to require a 36-inch guard from that platform, from that walking surface to a lower surface. And our handrails are 34 to 38 inches. There's 2 different types of handrails. Again, it gets very detailed about that type 2 rail, looking at perimeter length and gripping surface. If you got a question on it, yeah, just check the code, see what the language is. It's not worth trying to memorize, be honest. We need 1.5 inches of gripping space between the rail and the adjacent wall or a tread as we're using our stair components. They end in newel posts, safety terminals, volutes. I can stop them when I get through. They don't have to be continuous. Sometimes in commercial, we take them down and extend them on out and flatten them out and stuff. We don't have to worry about that in the residential realm. We had our guards in place, space between the walls, handrails. I think this is repeating itself here. I must have gone backwards. Apologize. This is hard to read, but it's an illustration showing a deck. So we come out on a landing, and there's our guard requirements on both sides, because when I went out horizontally 36 inches, at that point from the walking surface, I dropped more than 30 inches. So if you notice, within, say, 2 feet worth, no, I don't drop more than 30 inches. But when I got out to 36 inches, I was dropping a difference of 30 inches from where that walking surface is. That's the requirement for now putting a guard. It's only for the portion of the deck or landing that actually is falling off 30 inches. So if my grade started high over here and tapered through the yard, now when I had this landing, I may not have 30 inches of fall on this side. I don't need a guardrail on that side. But on the other side, the downhill side, I do, because it was the 30-inch difference. So it's only for the portions that reach that 30-inch minimum that you have to require it. Now, aesthetics may call for them to do more. We do want to have protection so that kids don't go flying through these rails. And so we look for allowances of openings that don't allow passage of a 4-inch sphere through a guard. Now, along stairs, we can get to 4 3/8 inch. And that's a whole nother story. But basically, the home builders came in and said aesthetically it didn't look nice if we had our landing coming over with that no more than a 4-inch sphere. And then when I started down the stairs and I had open stairs and I ran my pickets to the treads with a 10-inch tread and I started running pickets, I needed to run 3 pickets and they were really tight. And then it looked funny because I got open spacings, then I get to the stairs going down. So at that point, they said, can we go to 4 3/8, which begs the question of why don't I allow you to go 4 3/8 up at the top? But what do I know? I'm just, an engineer. So anyway, let's move on to our next slide, which is looking at window openings. If my window opening is going to be within 24 inches of the floor and on the outside, you're going to fall more than 72 inches. Now it calls for protection either by raising the window up or by putting in a device, a window, which is equipped with a catch mechanism so that it will stop and not allow passage of a 4-inch sphere without releasing it to go up. Or it has a little panel assembly that pops up, which is a fall protection device. Or we can put in some kind of a guard or some kind of a shield there to raise the opening up so that we're more than 24 inches off of the floor surface. Those are all options we can use. Now, the key is those windows with these fall protection devices or the opening limitation devices are manufactured to the ASTM F2090 standard. That gets you off the hook for making a determination about these windows when they are emergency escape and rescue openings, that they don't constitute special knowledge. So make sure that you're looking for that. That also tells me the window qualifies and puts the burden on the manufacturer should there ever be a problem with the window. It's the manufacturer's issue to resolve, not the jurisdiction or even the builder, unless they modified the window. So it makes sense. Now, sprinklers. The key thing to remember with sprinklers is it is not what we have in a commercial world. It is not the commercial sprinkler system that we see, which is for property protection. This one controls the room of origin of the fire for a given period of time, 10 minutes max, just to get somebody out of the room. The idea is the fire goes, we reach conditions where we have flashover, which means there's no hope for anybody in the room. The CO temperature is too hot. It's too much CO for people to breathe. Your oxygen temperature is too hot to breathe. You are getting smoke. You are getting a re-radiation of heat down. So we've reached about 1100 degrees Fahrenheit in the room itself. So things that aren't burning will combust. They reached flash points. They are going to combust. That's what flashover is. So what it's trying to do is control the room. If you think, let's go simple and just do the fire triangle instead of what it really is a tetrahedron. But let's go with a triangle: heat, oxygen, and fuel. Heat, oxygen, and fuel. And we're going to have that necessary to sustain fire. So if I remove any one of them, in this case, it's taking the heat away, then it won't sustain fire. So that's what it's doing. It's shooting water across basically the upper atmosphere of the room, trying to keep the room cooled down enough so that it doesn't elevate to the point where you won't be able to get out or somebody couldn't help and assist you out. And that was to gain 10 minutes worth of time roughly in a time frame. That's why it says a 10-minute water supply. It does not require fire pumps. It does not require, a emergency generator or any of the other bells and whistles that we would have with a legitimate sprinkler system. This is equivalent to what's in the NFPA standard for a 13D, standing for dwelling unit, sprinkler system. So don't read anything more into it. In fact, it is intended to be put in by the plumber when he puts the domestic water in, because that's what it's using. If you got a fire and we need to protect the room, then you don't need to be taking a shower. So it's going to use that water that's coming into the house. Now, the hard part is getting enough pressure and water supply to activate the heads, and we got to have 2 heads in the most remote location being able to activate the room basically furthest away from where the water enters the house. That's where we're trying to get this water to. If you're using a well pump to get water up there and the fire takes out your electricity, guess what? You're not going to get water up there, and that's okay. It's not great, but that's okay. We don't make you put in that emergency generator thing. So don't read more into this sprinkler requirement than what it is. But I won't lie, the 10 minutes worth of water can be putting in a tank, can be putting in an extra supply of water to get that water up there so that we could say it works. Anyway, these systems, there's basically 2 things from an inspection. One is before I start concealing stuff. The other is just the final. So there's 2 kind of parts. I'm going to let you all take a look at it. We have coverage on the heads, and this is any sprinkler head. It's got a certain amount of area it can cover if you have enough water and pressure to it. So we look at, did you exceed 400 square feet per head, or do I need more heads in the room? And we're going to make sure they're not obstructed. That's the big thing. So is there something that's going to block this water flow? And remember, it's not a bell-shaped curve like in a property sprinkler system. This is going to be shooting across the ceiling. So it shoots out from a sidewall, or it's coming down a drop head and it's going across the ceiling. So ceiling fans are a big problem. They're hanging down from the ceiling. They're going to block that flow of water. And they may, in fact, shoot it elsewhere where I don't want it. So we look for heads on either side to offset that. We also are concerned if you've got temperatures where you may put a wood stove or some heat appliance in, is it going to fake out the sprinkler system to where it activates the head thinking that, hey, it's hot enough, we got a fire going on, when in fact, the fire's in the fireplace and it's working the way it's supposed to, or it's in the wood stove, but the temperatures are elevated. So we put a different temperature rating on the head that is within proximity of those devices. So this table shows you we're typically looking at, like 3 feet away from an open fireplace, for example, with that head. Just making sure we don't get accidental activations. Pipe sizes would be spelled out in the submittals, and it's basically tied to your domestic water system. We have testing that can be air tested for those sprinkler systems. They're typically just plastic pipe that we're going to put in here. It's not, doesn't have to be copper or doesn't have to be any kind of metallic pipe. So that's the good news. They're real simple to run. And again, from a final inspection, it's verifying that we have it put in place. We've got signage on your water supply system to indicate that there was a sprinkler system there so that people don't inadvertently turn off the water thinking, well, it's not needed. Well, people are occupying it. They better have that protection. Last sections, I know I'm running out of time. Smoke alarms. Smoke alarms are what we've had for ages in the bedroom, out of the bedroom, on each floor level. And again, interconnected, battery backup, UL listed, making sure that one alarm of activation will interconnect and activate the other ones. One of the exceptions we had in the past was if you were doing retrofits and you weren't removing interior finishes, it said you don't have to interconnect them. Well, now with wireless technology, they don't give you that exception. So that would mean if I'm doing work which requires a permit and we're going to make you put in smoke alarms, that would also imply that you would go back and possibly have to replace your existing smokes with ones that are interconnected wirelessly so they all function together. And that can be a problem or a cost issue. We also don't want false alarming. And so what happens there is we will go and look for staying 3 feet from the bathroom door if possible. If not, then ignore it if it puts us too far away from the bedrooms, for example. We also want to stay 20 feet from cooking appliances if it's an ionization detection. If it has a silencing switch on that ionization alarm, then it can be 10 feet. If we're using photoelectric, we can be as close as 6 feet from the cooking appliance. And that's just to prevent the false alarm aspect, in which case you're going to ignore it. So again, keep those in mind. Must be heard over ambient noise, whatever that may be, in the bedroom. Good luck with that, especially if you got kids, teenagers. No, mine aren't teenagers anymore, but yeah, anyway. All right. Carbon monoxide, basically looking at if I have fuel-fired appliances or I have an attached garage which communicates to the house, then I need to make sure that we have gone in and we have looked at those applications and put in carbon monoxide detectors. If you have fuel-fired appliances in a bedroom or an attached bathroom, then they must also be in the bedroom, not just in the immediate vicinity of the bedroom. So first off, you'd have to know that the appliance was actually allowed to be in that location. So it has to be listed as such. And this is just a practice showing you that we've only got the one alarm, and of course we need them on each level outside the immediate vicinity of the bedrooms. Here's the UL standard for the individual alarms as well as for a system being put in place. And it has the alteration exemption where if I'm not removing those permanent fixtures, or interior finishes, I cannot require you to make them interconnected. However, that did get removed for smoke alarms. So 2021 code, guess what? Comes out in 2021 code. And there's practices for you. Now, the thing I want to leave you with is your workbook has a lot of tests in the back, and each of the sections you saw had some activities, but there's comprehensive building tests. Now, these are similar to, I know there was some discussion yesterday about practices you can do online for ICC. So here's one that you've already gotten, actually three that are for the price of one that you get with this book. So you can do one for the rough-in, you can do one for the foundation inspection, you can do one here for the building final that's back on page 349. Then you're going to have a comprehensive test for building that starts on 352, and that goes through a lot of different questions over to 361. So there's 43 different questions on that. And they're multiple choice. So similar to what's going to happen with your certification exam. So I encourage you to go through and check those and see how you did. As I mentioned, the answers are in the very back. And as I keep saying, if you're struggling, running into problems, having an issue, please reach out. Give me a holler. Let me know how you're doing. Okay, I appreciate your patience, especially this last session. Sorry it ended up being such a lecture type format. But before I release y'all for today, questions, thoughts, comments, anything for me? By the way, this is the last you'll see me this week. I don't promise, but. Yes, sir. Chris? Yeah. Mm-hmm. They're not required in the garage, no. What I'm saying is if you have an attached garage which communicates with the house, then you're going to trigger putting those carbon monoxides in the house. Yeah. Okay, well then the house is going to have it. Yeah, no problem. Anybody else? Thank you to those that are already kicking out, signing out.
Thanks for a good workshop.
Well, I hope it was helpful. I know we, covered a lot of ground. We didn't cover other areas which are contained in the book. That's where I felt comfortable. You can read those, and those usually aren't the stuff that creates a lot of controversy. But please don't be afraid to reach back out to me. Now, tomorrow you're going to have electrical. So you won't need the building book. You're still dealing with the electrical as it is contained in the IRC. So it's going to be those chapters out of the IRC that relate to the electrical provisions. And as we've mentioned, I think we've all kind of talked about it. It's coming out of the National Electric Code. So it's going to be based on just the residential requirements if you extract them from the NEC. Back in the old days, there used to be a publication that was just residential provisions, which took those and put them in a small pamphlet. Some of y'all may recall.
Hey, Mr. Gibson, thank you.
Hey, I hope it helped, Paul. Good luck, man. I want to hear that you passed.
I'll let you know.
You better.
All right, have a good one.
I expect good things.
Yes, sir.
Same time tomorrow for y'all, and it will be the same link. So just like you used for signing in.
Say, Dave.
Thank you for everything, John.
Thank you. Hey, y'all, I really wish you the best. And those of y'all who contributed here, Jamie, I got to tip my hat. Thank you for your contributions as we went through the past 2 days.
No, thank you for doing such a great instruction. It was awesome.
Oh, can I have that in writing? Yeah.
Absolutely.
Yeah. But no, it's a lot of information, and I just encourage y'all, don't get discouraged. That's the message we've been sending. It is possible to go through. All right, Chris, good to see you.
Thank you, John.
All right, brother.
For you.